The issue of disappearing 120 volts in an exterior lighting circuit, especially after adding a light and observing a voltage drop when a bulb is installed, suggests a few possible causes. The first possible solution involves a poor underground connection. As noted, a likely cause is a poor connection between the 14-gauge wires from the pole and the 6-gauge wires at the fixture. Excavate the area to locate the buried connection. Carefully clean and repair this connection. You can use wire nuts and electrical tape or, preferably, solder to create a secure, lasting bond. Ensure the connection is well insulated to prevent future corrosion or shorts. The second possible solution pertains to corrosion or damage to underground wires. Over time, underground wires are susceptible to corrosion and physical damage, particularly if they weren't buried correctly or protected adequately. This is more prominent in older installations. Replace any damaged or corroded wires with new ones. Use the appropriate gauge wire, either 14-gauge or 6-gauge, matching the existing wiring. Ensure the new wires are rated for direct burial and are installed according to local electrical codes. Thirdly, check for a loose neutral connection. A loose or improperly connected neutral wire at the fixture can cause a significant voltage drop when a load, such as a light bulb, is applied. Access the fixture box and carefully inspect the neutral wire connection. Tighten the connection securely. If the wire appears corroded or damaged, clean or replace it as necessary. A solid neutral connection is essential for proper circuit function. Fourthly, the issue could stem from a defective bulb or fixture. Though it may seem obvious, a defective bulb is a common cause of lighting problems. Try replacing the existing bulb with a new one of the correct type and wattage. If the new bulb also fails to light, thoroughly inspect the fixture itself for any signs of damage, such as cracks, corrosion, or loose connections. Replace the fixture if necessary. A damaged fixture can cause shorts or other issues that prevent the bulb from working correctly. Fifth, consider a tripped circuit breaker or blown fuse. If the circuit breaker for the exterior lighting circuit has tripped or a fuse has blown, it will cut off power to the circuit. Locate the electrical panel and check the circuit breaker for the exterior lighting. If it's tripped, reset it. If a fuse is used, inspect it and replace it if blown. If the breaker trips or the fuse blows immediately after resetting or replacing it, it indicates a short circuit or overload condition that needs further investigation. Now let's consider why the 120 volts disappears. The key to understanding the disappearing 120 volts lies in understanding what happens when the bulb is screwed in, creating a load on the circuit. When the bulb is screwed in, it draws current. If there's a high resistance point in the circuit, such as a poor connection between the 14-gauge and 6-gauge wires, it causes a voltage drop at the fixture. This voltage drop occurs because the resistance impedes the flow of current. According to Ohm's law, voltage equals current times resistance. So, if resistance increases, voltage decreases if current stays the same, or current decreases if voltage stays the same. In this case, the resistance at the bad connection limits the current flow, resulting in the voltage at the fixture terminals dropping significantly, potentially to as low as 1 volt, which is insufficient to light the bulb. To further elaborate on the technical aspects, let's consider the principles of electrical resistance and voltage drop in more detail. Firstly, resistance is the opposition to the flow of electric current in a circuit measured in ohms. Every component in a circuit, including wires, connections, and the load itself, in this case the light bulb, contributes to the overall resistance. Secondly, voltage drop is the decrease in voltage along a current path in an electrical circuit. It is a natural consequence of current flowing through a resistance. The magnitude of the voltage drop is proportional to both the current and the resistance, as described by Ohm's law. Thirdly, in a properly functioning circuit, the voltage drop is minimal and within acceptable limits, ensuring that the load receives sufficient voltage to operate correctly. However, in circuits with poor connections, corroded wires, or undersized conductors, the resistance increases significantly, leading to an excessive voltage drop. Fourthly, the connection between the 14-gauge and 6-gauge wires in your scenario represents a point of increased resistance, especially if the connection is poorly made or has deteriorated over time. The difference in wire gauge itself doesn't inherently cause a problem if the connection is solid and properly sized for the current. However, a poor connection between dissimilar metals or wires of different gauges is prone to corrosion and loosening, further increasing resistance. Fifthly, when you measure 120 volts at the fixture terminals without a load, i.e., with the bulb removed, you are essentially measuring the open circuit voltage. This voltage is present because there is no significant current flowing through the circuit, and therefore, no significant voltage drop. However, as soon as you screw in the bulb, the circuit is completed and current begins to flow. If the connection is poor, the increased resistance causes a substantial voltage drop at the fixture, resulting in the observed 1 volt reading and the bulb failing to light. Let's delve deeper into the implications of using different gauge wires and the importance of proper connections. 1. The American wire gauge AWG system is used to specify wire sizes. Smaller AWG numbers indicate larger wires, which have lower resistance per unit length and can carry more current safely. 2. In your case, the circuit uses both 14 gauge and 6 gauge wires. The 14 gauge wire has a higher resistance than the 6 gauge wire. If the majority of the circuit is wired with 14 gauge and it's properly sized for the load, the use of 6 gauge at the fixture is not necessarily a problem as long as the connection between them is excellent. 3. However, the transition between different gauge wires must be done correctly. Simply twisting the wires together and taping them is insufficient and unsafe. Such connections are prone to loosening, corrosion, and increased resistance. 4. The ideal method for joining different gauge wires is to use appropriately sized wire connectors, such as wire nuts or crimp connectors, that are specifically designed for joining different wire sizes. These connectors provide a secure, low-resistance connection and help prevent corrosion. 5. When burying electrical connections, it's crucial to use direct, burial-rated connectors and to protect the connection from moisture and physical damage. This can be achieved by encasing the connection in a waterproof enclosure or using heat shrink tubing designed for underground use. 6. Let's discuss the potential hazards of a poor underground connection. A high-resistance connection can generate heat as current flows through it. This heat can damage the insulation on the wires, leading to short circuits or ground faults. 7. In extreme cases, a poor connection can even cause a fire. Additionally, a damaged or corroded underground wire can create a shock hazard if someone comes into contact with the exposed wire. 8. Therefore, it's essential to address any issues with underground wiring promptly and to ensure that all connections are made safely and correctly. When excavating to locate the buried connection, exercise caution to avoid damaging any underground utilities such as gas lines, water pipes, or other electrical cables. 9. Before digging, call your local utility companies to request that they mark the locations of their underground lines. Dig carefully by hand around any marked utilities to avoid damaging them. 10. Consider the local electrical codes and regulations that govern exterior lighting circuits and underground wiring. These codes specify the types of wires and connectors that are permitted for use in underground installations, as well as the required burial depth and other safety measures. 11. Ensure that your repairs comply with all applicable codes and regulations to ensure the safety and longevity of your electrical system. In addition to addressing the immediate problem of the disappearing 120 volts, it's also a good idea to inspect the entire exterior lighting circuit for any other potential issues. 12. Check the condition of the wiring, fixtures, and connections at all of the lights on the circuit. Look for signs of damage, corrosion, or wear and tear. 13. Replace any components that are in poor condition. 14. Consider upgrading the wiring to a larger gauge if the circuit is heavily loaded or if you plan to add more lights in the future. 15. Performing regular maintenance on your exterior lighting system can help prevent problems and ensure its safe and reliable operation. Now, let's summarize the key steps to troubleshoot and resolve the issue of the disappearing 120 volts in your exterior lighting circuit. 1. Turn off the power to the circuit at the circuit breaker or fuse box. 2. Excavate the area around the buried connection between the 14 gauge and 6 gauge wires. 3. Carefully expose the connection and inspect it for signs of damage or corrosion. 4. Clean and repair the connection using wire nuts and electrical tape or solder, ensuring a secure, low-resistance connection. 5. Replace any damaged or corroded wires with new ones of the appropriate gauge and type. 6. Check the neutral connection at the fixture and tighten it if necessary. 7. Replace the bulb with a new one to rule out a defective bulb. 8. Inspect the fixture for any damage or loose connections. 9. Reset the circuit breaker or replace the fuse if it has tripped or blown. 10. After making the repairs, turn the power back onto the circuit and test the light to ensure that it is working properly. 11. If the problem persists, consult a qualified electrician for further assistance. Electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable working with electricity, hire a licensed electrician to perform the repairs. A professional electrician has the knowledge, skills, and equipment to diagnose and repair electrical problems safely and effectively. They can also ensure that your electrical system complies with all applicable codes and regulations. By following these steps, you can effectively troubleshoot and resolve the issue of the disappearing 120 volts in your exterior lighting circuit and restore power to your yard light. Proper electrical maintenance and safe practices are essential for ensuring the safety and reliability of your home's electrical system. Remember to always prioritize safety when working with electricity and to consult a qualified professional if you have any doubts or concerns. This comprehensive approach should help you tackle the problem and keep your outdoor lighting shining brightly. Always remember to use appropriately sized connectors and wires, as well as proper burial techniques. Following all of these methods should ensure proper lighting of your yard for years to come.